In this first video, I'm just going to show you how to resolve horizontal and vertically a coplanar force. Now, when you deal with coplanar forces, all that means is that it's forces that act within the same plane. So if I was just going to take a very simple example, here I have a particle, and on this particle I'm going to have a 25 Newton force that's not acting in either the horizontal or vertical, it's actually acting at an angle to the horizontal. I'm going to set that angle to be 60 degrees. Now, in Unit 2 and Unit 4 maths, angles that act at random angles to the horizontal or vertical are no use to us. What we need to do is find out their component parts, i.e. in the horizontal and the vertical. Then we can look at the forces acting on this particle in the horizontal axis and the vertical in turn. So what I'm going to do is I'm going to basically create a triangle of forces. So in this case, I'm going to create a nice little right angle triangle, which has a horizontal component and a vertical component. Now, if we use our trigonometry, we would know that this side would be labelled the opposite, this side the adjacent, and this side the hypotenuse. What I'm going to do now is actually just use some of my trigonometry skills to basically from GCSE to solve the horizontal and vertical component. So if I was going to look solely in the vertical, the first thing I notice is I have the hypotenuse and I want the opposite. So I know that's going to be sine. So I know that sine 60 will equal opposite over hypotenuse. Well, I've filled in the bits I already know. So my opposite is going to be 25 sine 60. So in the vertical, that component of the 25 Newton force will begin as 25 sine 60. And that comes out to be 21.65 newtons. Now, what's happening in the horizontal? Well, if I look in the horizontal, then I can use my trigonometry facts again, and I've got adjacent, I want adjacent, and I have hypotenuse. So I would then write cos 60 degrees is adjacent over hypotenuse, so it's a over 25. So therefore, my horizontal component will be 25 cos 60. Working that out on your calculator, that would come out to be 12.5 newtons. So what I have now is a horizontal force of 12.5 newtons, a vertical force of 21.65 newtons, and therefore now I can do resolving of forces in the horizontal and vertical. Obviously, I've just shown you a particle with one force acting on it. Obviously, in your exam, you'd have 3, 4, even sometimes 5 forces acting in different angles. If I wanted to double check my working, because I have this triangle of forces now, I could apply Pythagoras' theorem, and we could then work out from my two components what the resultant force is. Now we know the resultant force is the 25 newtons, so if I was to do a quick calculation, I would want to know whether 12.25 squared is equal to 12.5 squared plus 21.65 squared, and in fact, if you do that calculation, you'll find that that is correct.